So, good morning, everybody. Welcome to day 2 of the GSC UK virtual conference. I'm delighted to have Mary Solomon presenting now. This is session 8F. Because it's pre-recorded, as some of you will have heard, probably a good idea to you can type the questions in, but Mary will answer them at the end, I think. Okay, over to you, Mary.
Yeah.
Oh, sorry. One other thing, that do use the QR code, folks, please, to feedback. We do appreciate understanding how well it went for you.
Good morning. I am Mary Solomon. I'm working as a consultant in SMT Data Denmark since 2018. I have been working in mainframe performance and capacity management last 10 years. Today, I'm going to share my batch performance presentation to you all. It's a pre-recorded presentation, and I'll be available to answer all your questions in the end of the session. And thanks to GSC UK and SMT Data for this opportunity. Yes, this presentation, how put it my experience with the customer, whatever I have experienced in the batch, not everything. I have put it some of the very few things about batch and WLM, few concept about WLM and disk IO and resource group, interval 30 record and delay reports and everything. I hope you all doing good. And today I'm going to talk about various approaches in batch performance. And before that, thanks to everybody finding some time for me to attending this session. First of all, what is batch? Batch is a piece of programs that are assigned to the computer to run without any human interaction. And it will access the bulk of data, perhaps terabytes of data, and produce the load of output. It's like a payment and billing statement, etc. Mainframe are typically equipped with a tool, job scheduling tool that will allow system operator to control the batch and to manage and track the execution and see the output of the batch. Batch is something like a chain. If something is going wrong in between that one, it will stop the entire flow. So sometime in the banking environment, batch have a very high critical SLA. If something is going wrong, they should get a message or the call from the operator to fix the problem. And the fourth point here it is. If you want to start your batch, if you want to submit the batch on the mainframe, first of all, we have to think how much data storage we need, how much processing capacity we should need to process your batch. It's always good to know the data, how much data storage we need and how much processing the capacity. And the third one is we should need a very good job scheduling tool to control and to monitor the batch. The next slide. Here you can see in the right hand side, I put it some colorful diagram. That's my own imagination about the batch. You can see some system operator or system programmer. That's me actually. I'm sitting and thinking about what all the work, whatever I said is batch is nothing but a piece of work. You all know about that in the mainframe. We have a lot of piece of work on the mainframe. So like daily, weekly, monthly, billing, payroll, report generator, etc. Many things. So that's all the piece of work. Batch is nothing but a piece of work, and it will access the large amount of the input data, large amount of the output data, and hundreds and thousands of the jobs in a pre-established sequence. And the batch window, yes, batch window also one of the main topic to discuss in the batch performance. Generally, batch window, it will start after the online workload, like 17 after the online window, 17th hour, it will run the entire night, even in the early morning up to 7 o'clock. It should complete before the online window. Generally, I'm talking about that. If it's in the modern system, right, we can see sometimes batch also running together with the online window. That's in the different case. And talk about the job dependency. Yes, we should know actually for what is the dependency. For example, if sometime your batch is waiting for some data set because another job is using the data set in exclusive mode. Then your batch job, it wait for the data set. You don't want to get into the data set contention. At the same time, you want to know what is the input for your batch. For example, if your batch job is have a dependency, the previous run job, it's wait for the previous job to complete, then your batch will complete. So just to understand before you start your batch flow, what is the dependency, how much you need, how much processing capacity you want, how much memory you want to process the bulk of the data. So just to make sure to understand the overall requirements of your batch. And coming to the SLA, yes, whenever even I used to talk to all my customer, I'll give a first priority for all the online workload. We'll give a very good SLA for online workload all the time. We'll talk about that and all the time too. In your environment, also you will talk more about online workload is. But for example, if it's a banking environment, batch also have a very critical SLA. Very recently, I had a very good conversation with one of the Nordic bank. They are uploading the customer banking statement. They updating the employer salary. In every month, the particular time. It's doing by the online workload, and they're using the Tivoli workload scheduler tool to handle that one. So then I got it how batch also have some critical SLA. It how to update the customer bank statement on time. Otherwise, it's going to be a very high critical incident for them. So batch also have some very critical SLA. Just think about it in your environment. Next slide, batch at the night. Yes, as I said, batch always start after the online transaction. In generally, I'm talking about that because we can see, even you will see there is a lot of batch jobs in the night time and in the early morning time, because the reason is the batch will use, few batch will use the online output as the input of your evening batch. Then it will run all over the night and in the morning time. Backup of the critical files. Yes, the batch will read the data. Maybe it will overwrite your data set. If you feel if it's a very critical file, it's good to take the backup of your critical files before you process your batch flow, because you don't want to end up in the situation you lost the data or something like that. The third one, monitoring the messages. Yes, whatever I said in the previous slide, batch is like a chain. It how to run step by step. If something is going wrong in between, it can't continue the flow. So operator have to monitor the messages. If something really going wrong, they have to communicate with the concerned team or the job owner to continue the batch flow. Yeah, jobs are reading and writing the database. Next slide is about the batch flow. I put it some of the simple area graph. It will be, maybe you can't see in the x-axis is a hour. 0 to 23 hours. It's a 1 day data. And this is y-axis is a MIPS number and all the workload like system, STC, online, TSO and batch. And the blue one is the batch and the green area is online. I put it 2 black line to show the online window and batch window. During the between 6 to 19th hour, you can see the green area is very high. The meaning online is occupying the time. That's a business hour. And after the 19th hour, and you can see the blue is starting. The meaning is online. After the online, batch is starting the work, and it will run the entire night. And you can see in the 0 to 1 2, it's going up to 15,000 nets, and then it reduced. You might also see the same kind of job flow in your environment, and you can see some of the white space between patch window and online window. It will be because there is a reason behind for that one, because the customer is following 4 hours rolling average, or if they're paying for the group capacity limit based on the 4 hours rolling average, they always maintain the white space here. I know this customer is following that one. They want to need some white space between batch and online to get a very good capacity to start the online workload at 6 to 7 o'clock. Just imagine batch is not completing at 3 o'clock. If it's coming up to 6th and 7th hour, what it will happen at the 8th hour? If it's following a 4 hours rolling average, 8th hour, I'm sure it going to get into the capping and online going to get the CPU constraint, then it create a performance problem. We don't want to end up into that situation. That's why we always maintain some white space between batch and online. But nowadays, you can see some of the customers are moving to the TFP, tailored fit pricing model. Then we can use this white space also. That is the one of the advantage. But still, if batch is coming very close to online and if it's take a same amount of the CPU, that's not good in terms of the performance. Then we have to look at what's the top patch and why it is taking the high CPU. The next slide about the top patch analysis. This is one of my favorite report when coming to the top patch analysis. The reason is here you can see the type 70 and here you can see the type 72 by workload, and here is a type 30 by address space. Because maybe the load of so many graphs don't get into the confusion, because I'll just explain here a little more. Here, this is type 70. You can see the configuration of the system, how much the zip weight in MIPS and CP MIPS in weight, and how much zip is used, how much CP MIPS is used. 22nd October, zip MIPS is consumed a lot, and CP MIPS also consumed a lot, and it went above the CP MIPS weight. There's nothing wrong in going out of the weight limit, because it taking other LPAR capacity, but at the same time, you will be curious to know what exactly happened on 22nd October. Who is the reason for the high CPU usage on 22nd? Then you can see it here as a type 72, and it's showing by the workload, and blue color area is really high on 22nd October. The blue is nothing but a batch. Batch is consumed high from 22nd October, 0th hour to 16th hour. Then what is the next question? It will come in the batch. Who is the reason for that one? You really want to know the address space. Which address space is the reason? Then you want to know the top 15 tasks during that time. I didn't select anything here, which workload, but here it's showing together STC and system. What is the top 15 tasks the entire period? Next report, I can show you how to select the batch and how you will get to know the top 15 batch. And here you can see the different wait time from type 72, CPU wait, disk IO wait, this server wait, and memory wait. This is also one of my favorite report to identify if some batch or STC really waiting for the memory, or if it's waiting for the server, or it's waiting for the disk IO. If your batch is waiting for the disk, you will get it more the yellow color, because yellow is indicating the disk IO. You will get more yellow bar graph. Then that is the point here to understand. You can improve your disk performance then if you're getting a more wait time. And here 4 hours rolling average, yes, it's from type 70. So that is the reason I said this is one of my favorite report. Next slide, the same report, but I have selected only the batch. And you can see it's a little highlighted, the blue bar graph. And if you select that one, then the top 15 automatically it will modify, it will show the top 15 tasks during that time. You can see my top task is a batch 1, 2, 3, 4 because it's like a demo data. I can't show you the real batch, but if you use this one, you will get to know the batch name, what consumed high during that time. Next slide is a workload balance. And right hand side, you can see some beautiful graph. It's a 1 day, 0 to 23 hours here. And this is the MIPS number and all the workload, how much is taking average MIPS per hour. Yes, when I see such kind of a pattern, workload pattern, batch is starting at the 0th hour and it ending at 6th hour. And online, yes, as usual from 8 to 16. But when you see such things, I'm sure this customer is paying for the bill for the batch peak. This is happening every day on their system, not in a 1 day. So they're paying for a payment based on the batch peak, not for the online peak. You can see how much is exactly taking online is approximately 1,600 MIPS. But batch is going together with the system and STC, 3,200 MIPS approximately, right? So it is the good to continue the business like that, but because if you are the performance person, but we will think about like that. No, we have something like a white space in the evening time. We can make use of that one. So we can offload some work from 0 to 6th hour to evening. We can start some test batch or some prod batch if it's depend on the online transaction output. We can start at 19th hour or 20th hour. So it will start the entire night. It will complete in the morning time. First one. And the second point is, if you see everything in the dark blue color, and you have something like a batch test service class or batch medium, you can offload some of the workload into another service class, another workload. Because to balance the work, we have a very good technique called WLM, and we have to make use of that one. There's nothing wrong in keeping all the workload in a one service class, but we have to make use of the algorithm of the WLM. So we have to give the less priority batch into best batch test and high batch into batch high. So balance your workload based on your priority and SLA. And the third point is you can make use of the resource group. For example, you don't want to use 3,200, but you want to make use of only 2,800. You can make it as a 2,800 as the resource group limit. Resource group limit is act exactly like a hard limit. So it can't go more than 2,800 the batch. But the thing is, if you make the resource group, it will increase the batch elapsed time. So it might end up 8 hours. So that's not a good idea in this situation. So we can't do that one. But the fourth point, we have to find out the top batches during this time, first thing. And we have to use IBM have a very good tool called APA, Application Performance Analyzer, and Strobe. We can make use of that one to understand the batch logic, which step is taking a high CPU and what could be the reason. If anything, we can able to modify, we can modify the script or a code that will create the permanent solution in the batch performance. So that could be the good improvement, because some of the banking and insurance company have a very old programs, SAS or a COBOL or the batch program. So you can understand, you can revisit the logic and you can make it more efficient in the batch performance. In the next slide, it's about the WLM. Here also I put it some table data here as a workload and service class and different WLM importance. This is the two-dimensional table data. It's based on the workload and service class and the WLM importance. Here I'm going to explain how WLM importance working, what we have to think about it. Yeah, batch, yes, I have highlighted in yellow, and here batch 01, batch 02, batch 03. Batch workload divided into 3 different service class. And batch 01, it is in importance 3. Batch 02, it is in importance 4. Batch 03, 02 in importance 3, 03 into importance 5. And you can see the different percentage of the group. All different importance have a different percentage. Sometime I have observed some customer keep more than 60, 70, 80 percentage of the work into importance 2 or importance 1. It's nothing wrong in keeping all the workload in one importance, but we have to make use of this WLM to work in a better way, because if you think about it, you put it everything on one importance, that's going to be a burden for WLM. Like your job will wait in a longer queue. So we don't want to end up in the situation. So we have to think in the efficient way to make use of the different importance in WLM. So when the system is overloaded, WLM give the first priority to the batch 01. Then it will give importance to batch 02. Then it will come into batch 03. I feel it is good to divide the batch into the different groups and based on the priority. That will improve the performance. WLM importance is relevant when system is overloaded. WLM uses it to decide which workload goals are most important to satisfy. And the WLM importance tells the ZOS workload manager how important is to meet the goal relative to meeting the goals to set for the other workload in the Sysplex. And you can see this diagram, system and STC always in the higher priority. And the highest is a 1, high is a 2. Generally, all the transaction workload will use these two kicks or DB2, DDF. Yeah. And medium and low and lowest for the, you can decide which one you can give it for your batch. If it's a high batch, you can give us a high, otherwise medium. If it's a low batch, based on the critical and based on your SLA, you can use the importance. Okay, now I'm moving to the disk IO weight. How disk device is influencing your batch performance. I'm going to share some of my experience in this one. Yeah, now you can see some multicolor diagram. Don't get into the confusion because I will explain. The below one is a hour and the date is 2-month data actually. And here you can see the percentage and all the colors. The explanation is here. Memory weight, server weight, disk IO weight, disk IO, CPU weight, and CPU. Here I'm going to talk about the disk IO weight. And the line you can see it's a before disk upgrade and the line after the disk upgrade. Before the disk upgrade, the yellow is around 15 to 20%. Is a disk IO weight is a 15 to 20%. And you can see after the disk IO, the yellow graph bar, it's reduced to 1 to 5%. Yes, it's a good improvement. After the disk upgrade, the disk IO is improved. So batch is not waiting for the disk support. It's getting a very good performance. If it's not waiting for the disk, I'm sure it will indicate you, right? Batch is reduced the elapsed time. So it's improvement. And you might think what happened in between the before disk upgrade, there is a lot of yellow color. That is like something went wrong. I know the reason, but today I'm not going to talk about the disk device so much. So we'll move on to the next. Disk device, whatever I said in the previous report, it's same related to that one. This graph is showing a one batch of CPU usage at the same period of the before disk upgrade, after the disk upgrade. Before the disk upgrade, the one batch is consumed approximately 4,800 CPU seconds. What happened after the disk upgrade? It approximately consumed 4,400 CPU seconds. Here I'm showing only one batch. This customer might have 100 or thousands batch. We have to find out all the batch how much CPU is consumed. So you can see after the disk upgrade, the CPU usage is improved. And I didn't put it as the elapsed time of the batch, but I have checked after the disk upgrade, how is the batch elapsed time? That is improved a lot, elapsed time too. So the point here is when you do the device upgrade or when you're moving from Z13 to Z16 or Z14 to Z16 or Z15 to Z16 or doing any upgrade or disaster recovery DR test, whatever it will be, it's good to check your batch performance because you're getting a new disk device. You really want to know how it is helping your batch performance. You want to know how much CPU you can able to save out of the new disk device. So it always good to check your CPU and your elapsed time and all your batch wait time analysis. Next, I'm moving to the resource group. Resource group, it's one of my favorite topic when talk about the batch performance. The thing is here, I put out some beautiful graph. Here, it's by hour, 0 to 23 hours, and you can see the MIPS number. And yeah, and this data from November 1st to November 29, it almost 1 month of data, and every day how much it's going every hour. It's going actually fine, but when coming into the 6th hour, it really want to go above that, but it can't go more than 248 MIPS. That is called resource group. That's the beauty of resource group. If you want to really control your batch, if you feel the batch don't want to run so much during online time, you can use resource group. This customer is using a resource group between 6 to 16 and they have decided to keep only 248 MIPS as a limit. And you can see the 16th hour, it's suddenly jumping from 248 MIPS to 1300 MIPS. So that's fine. After the online hour, it can use it. That's okay to them. So yeah, this is the way we can control the batch during online hour. If in your environment, if batch is taking if your test batch or if the less priority batch is taking a very high CPU cycles during online time, just think about the resource group. It will help you to give more capacity for online workload. Yes. The next slide is showing about the resource group overview, and I have made this report for my own use. I thought of sharing with you what is the meaning to the benefit out of this report. One of my customer have more than 6-7 actually resource group. It's a complex environment. They have many resource group, and to make me and my customer clear, I'll have the LPAR, which LPAR have the resource group and which workload have the resource group. and the name of the list of resource group 1 to 6, and the mapping between the resource group and the service class. Resource group 4, you can see prod, report and online test workload, and resource group 1 for STC01. And here we have all the weekdays. Why I put it on the weekdays? Because you might also have some such case in your system. Some people don't want to keep resource group for the Tuesday to Wednesday. They want keep it only for Monday because Monday is a busy day. They want only resource group on Monday. To want to get a more clear picture from out of all the resource group, what time is active, what time it's not active, and which day is active. To get a more clear picture, I used to maintain like this. So in the below table, it's showing about 0 to 23 hours in the top number and all the resource group. For example, resource group 1 is active from 0 to 7th hour and 8 to 15 is completely white. The meaning is the resource group is not active. The particular service class is it's out of the resource group during this time. And 16 to 23 is active. All this number is how much the resource group is average MIPS number the particular hour. And for example, resource group 6, it's completely white between hour 0 to hour 5, and 6th hour it's starting as a green. If it's a green, meaning the resource group active from 6th to 23 hours. So the report will always give some overview for me to understand, like, yeah, this has happened. If they add new resource group, it will come in the report, then I can get to know some more clear picture about the definition. The next slide, here we're talking about the different type of the resource group. We have a 4 different type. One, we can do it based on the CPU service unit. CPU service unit per seconds. That resource group, the scope within the sysplex, and you can define minimum and maximum. The second type, you can use the LPAR share in general processor. LPAR share is nothing but your LPAR weight. If you have 100 as your LPAR weight, you want to give only 30 to batch, you can make it as a 30 for the particular workload. I can show you some later, some table data. So from SMF record, you will get some clear picture of this one. But LPAR share work, the scope is within the system scope, not a sysplex scope. And number 3, it's about the general processor, CPs. Has this within the system scope, and for example, general processor is nothing but if you have a 3 CP processor for your LPAR and you want to give only 1.5 to your batch, you can make it that one as a 1.5. You put it the definition, then it will take only 1.5. And fourth one is MSU. You can keep MSU number also within the sysplex scope, it will work. And some of the note from the resource group, whatever you keeping the capacity limit, that includes both the TCB and SRB. And the resource group, the minimum, whatever you defining as a minimum can equal to the resource group of maximum. And maximum, whatever you're keeping the maximum limit, it applies to all the service class within the resource group, and maximum is enforced. Minimum is always the default is 0. The minimum capacity setting has no effect when work is the resource group is meeting its goal. Next slide is a resource group. Here I put it some, here onwards you can see some of the lot of data and tables. In my current job, I have to work with a lot of SMF data to understand. So I thought of sharing some of my experience with you all, some of the SMF variable names. So it might be useful for you when you make some report from SMF. This is one example based on the LPAR share. LPAR share is nothing but the LPAR weight. I have highlighted only 3 variables here. From type 72, you can see R72 3GGMN is MXG names, and the GMN is showing about the minimum whatever you defined in the resource group, and the maximum is GMX, and GMN, this one it's showing about if the resource group defined the minimum, you will get it as S, Y in all the columns. Yeah, in the real time in a mainframe, you can go to WLM, you can see directly what is the definition for your resource group. You can get to know that one. You end up to work with SMF data, then you really want to know the definition. Type 72 is a very good data to get to know your resource group setting. Or, for example, you move to another resource group setting, you really want to know what is there in the 6 months before the resource group. It's good to know from your SMF data. SMF data is always the golden source to get to know your system. And here you can see the resource group name and resource group description. And the minimum is 0, maximum is 30. Whatever I said is LPAR share, this using it. This LPAR might have more than 30 as a weight, but they're using only for 30 is a weight for batch prod workload. The next slide, resource group for the KICS region. You cannot assign the resource group for the transaction-oriented work. KICS and, for example, KICS and IMS work transaction. But you can assign minimum and maximum limit for your Apple ID or a region ID. I put it some example. This is based on the MSU limit. The online test workload, they created the resource group and they put it as a minimum is 0, maximum is 98 MSU, and they didn't put anything in the minimum is not defined. That's why it's nothing. If they put it as a minimum defined, it will come as yes, yes, yes in all the place. And type 72 have MSU 72 as a variable. Whatever you're seeing in the table header, it's all type 72 SMF names. So you can might be relate with your data. So MSU 72 showing the workload MSU usage, and you can see 35, 34, it's growing, and it coming up to 91. It's interval, 30 minutes interval data, and it's 91. It might went into close to 98 also. It might need next interval 98 also, but it can't go more than the limit. So it will reduce to the minimum. So yeah, that is the way it will work. The next one is a resource group service unit. I said we can use service unit. One of my customer is using service unit resource group limit. I can show you something here. Yeah, this table is showing at the 20 minutes interval type 72 data, and the resource group is limit STC. They want to use it for STC task, and minimum is 0, and the maximum they defined as a service unit, but this is per second, not at that interval. Yes, this is a little tricky to understand here, because when your data in SMF is a 20 minutes or a 30 minutes or a 1 hour interval, whatever it will be, but this is per seconds. You have to calculate at that interval what is the maximum limit based on the service unit. So here I have a calculator to show you the maximum limit is this much, because the data is a 20 minutes interval data. This into 20 minutes interval, then the higher number. For example, here you can see that number is more higher than this. It can go more than, because there is no resource group during the time, but during the resource group time, it can see it can't go more than the maximum limit. The next one is resource group and the batch behavior. Here also you can see there is a lot of data and numbers and everything, but let's focus on the graph. Here is the MIPS number and from data from August 1st to 29th, and the above table is showing date and the hour. There is one batch. The batch name I have selected only one batch. It started at 13th August 0th hour, and it's taking 1,000 MIPS. When coming to the 7th hour, it's coming reduced to 123. It can't go more than 123 during the 7 to 15. When it's hitting the 16th hour, again it's going to 1,364 MIPS. It started Saturday 0th hour and Sunday it ran completely, and Monday is 15th August. The job owner's back to work at 10 o'clock, and he or she is observed is something going wrong, and they stopped the batch. This is the test batch, is a typical example. Really batch sometimes take a very high CPU. If, for example, the job owner is out of the work on Monday and Tuesday, think about it. It will continue on your Monday, Tuesday work also. It will disrupt or take a lot of CPU cycles. So the two things we can see it from here: how resource group is working and why it is taking a high CPU. The thing, if I see such kind of a high CPU usage of the batch, I really want to know what exactly they're doing it. You have might have something real time. You can get to know something what exactly. If you are out of the office, you coming after a 1 week or a 2 weeks time, you really want to get to know from your SMF data. Next slide is showing about from the same batch the behavior in DB2. Here also there is a lot of numbers, but I have highlighted something for you. The same batch job you will see from DB2 101, and it will show the what plan they're using and what packages they're using. And what package is a Rex SQL program. And it doing the DB2 call connection. Lot of very good information from 101 DB2. You can relate your batch with the DB2 data, and you will get to know what exactly they're doing on DB2. And 28,000, don't get into the confusion because it's a very high number in DB2 because the data is based on the transaction in time, that is accumulated MIPS number. It's not at the interval record. So it's showing the accumulated number. That's why it's really a high number. But the good information is a Rex SQL program. They started on Saturday and it taking a high CPU. It's all good information to tell to the developer to look at it what. And the next slide about the interval 30 record. It's also one of my favorite subtypes about the subtype 5 and 4. 5 is talking about 5 is for the job termination event, 4 is for the step termination event. Two different data here, table data and job number and the job. It is showing what time it started, what time it's ended, and totally how much is consumed. 3,530 CPU seconds. When I see such things and I will see what step and what program is using, that you will get it from the subtype 4, interval 30 record. Subtype 4 showing the same job and the same job number. You can relate with the two data and the step number 1. And the program is PP87 is consumed 3,530 CPU seconds. So PP87, if when you talk to the job owner, you can tell this is the step and this is the program. It's taking a high CPU. That's a very good information for your developer. And the second job is a SaaS job. It's taking a high CPU. Yes. So the beauty of these two things, you can relate each other and you get some meaningful information out of that one. If you make some programs and it can show you every day, it will send you something like a top 10 jobs from the jobs and steps. That will be a good information when you want to do some batch optimization. Next slide about the delay report. RMF have a very, very good delay report you can see in the real time. But You want to know 6 months before from your SMF record or the previous Z13 and Z14 when you do the comparison. So you want to do it based on the SMF record. Type 72 have very good delay reports, delay data. And here I put it some of the delay variables from type 72. I want to show you two things here. One is like a PCT DLCCA and PCT DLCDA. CCA, it's for the CPU capping delay. It's including the capping delay. And the next one, it's not including any capping. CPU delay percent not including the WLM capping. It's not included your resource group capping delay. So these two things, and there is other lot of delay variables from type 72 like a queue delay, total queue delay time. And here you can see that it's in the seconds. I put it as a seconds, and the ideal delay DASD. The batch is getting a very good response from the batch DASD, so that's why everything is 0. If it's not getting a very good it's waiting for the DASD support, maybe you will see some higher number. Unknown delay. Unknown is outside WLM delay. It's maybe if you see some of the SAS job will get into a lot of unknown delay and a lot of JCL conversion, queue delay and everything. We don't have so much time to talk so much about on this one. We'll move on to the next batch CPU usage in DB2. I thought of showing to you how I will relate the batch job in DB2. The first one is SMF 30. The second report is DB2 101 package information. You can relate two things based on the job name. The job name, how much is using in interval record, and the job name, and you will get to know which package and how much CPU is using and how many transactions. That's a beautiful information actually 101 is giving. I'll put it a little more clear in the next page. Is a little more clear about the 101 DB2. Lot of numbers, don't get into the confusion because I have highlighted everything here. The plan name is here and it's a TSO batch connection and the subsystem. And the job accessing different packages, but there is only one package is taking a high CPU. Nothing wrong in taking a high CPU, but sometimes you have to see what is the pattern for the last 6 months. Every time it's taking 100, 159, 49, 28. What happened on October 11th? It went up to 6,000 MIPS and 4,000, 3,000. Something changed or something happened. So it's good to inform them if they have modified anything. You have to tell them your program is going high and they can check it out and they will fix it. After that, it go back to the normal usage. I have a lot of things I covered in this webinar about WLM, Disk IO, and the resource group. I put it together, some of the experience in this webinar. So the conclusion is, since batch plays a major role in terms of both cost and the performance in the mainframe. So I feel it's worth doing it. I hope you also feel the same thing. Thank you so much. And you can see it here, my email address and LinkedIn page. Please write it to me if you like my webinar, and if you don't like it also, no problem, and put it on that one. And if I put it anything wrong, you can point it out. I'm happy to see that one. And thank you, everybody.
Any question for me? Martin, you are in mute.
You're supposed to lip read. Well, that's probably a joke in poor taste. Oh, the sun has come up somewhere in Denmark.
I'm really today Denmark is bright. Generally, always be the great during this February month. But I'm really happy today that I'm telling morning to my friend. Today I'm going to share my webinar in the GSC UK. That's why today Denmark is very bright.
Right. It's probably very cold as well. Okay, at this point, we don't have any questions in the chat. We've got a few minutes left for questions if people would like to ask them. So please put any questions you've got, folks, in the chat. I was going to make one comment just to kick the ball off, and don't worry, I think it's a reasonable one. Those fields that you said from MXG, from MXG, which is obviously what you're using, I would just point out the ones starting R7 something are direct analogs or mangling slightly of what RMF produces. So, and the reason why I make the point is only that if people are using something else, and I'm one of those idiots who's using something else. Yeah. If they start with R7 something, you probably can directly process the data with whatever tools you're using. So I think it's just worth noting that. Okay, any actual questions? Let's give it a couple of minutes. Right, Mark Roper. Have you ever managed to use graphs to match the performance issues against costs so that it makes it very apparent how much return on investment there would be?
Yes. Whenever we make the MIPS number, we always care about the money cost. So we will relate how many, like 1 MIPS equal to how many Danish kroner or Norwegian kroner or Finnish. So we will translate and we will translate MIPS into the cost, and we will advise the customer based on the MIPS usage and even the cost.
Right, because I think one thing that's worth saying is that tuning batch can be quite fiddly, and therefore you need a case, right? So the estimated savings is probably quite important in building a case to do anything at all.
Yes. We will translate when we batch is taking a high CPU, even during this online or outside online peak period. We will translate the MIPS number, how much the batch is taking average, and we will translate into the money. Yes, we will advise based on the numbers.
Right, Mark's actually followed up with, okay, so only on MIPS, not the disk or upgrade of processor.
What exactly? I didn't get.
Okay, so only on MIPS, not the disk or upgrade of processor. And just to be cruel, I'll add in not memory either, but
yeah. When we do the disk upgrade, when you move from old to the new device, we calculate what is the difference between the MIPS usage at your batch before in the old disk device and how much it's taking in the new disk device, and how much the difference between the MIPS number and the CPU cycles. So we will translate into the money, and we will tell them when you move into the new disk device, and this is what you got it. This is the benefit you getting out from the new DASD device.
Right, Mark, I'm gonna ask to unmute you because you made a comment that this is a bit difficult to do in a text mechanism. So if you want to try it with your voice, here's your chance.
Can you hear me now?
Yeah,
I can. Yep. Go for it.
Okay. Change it. Yeah, so difficult to do this on text. I was more, it's there's a cost to everything, and obviously I know everyone focuses on MIPS, and so we always have clients who they want to run the machine at 98% because they want every single MIP used. But obviously when you show all your graphs, which was really great in the presentation, you know, you're showing that a disk upgrade would really impact the performance, but that disk upgrade comes at a cost. I have no idea what those costs are. Also a processor upgrade as well, going from a Z13 to a Z16, yeah, of course you could get massive returns on that, but the cost against that cost. And when you can show it as a graphical, you know, this is how your costs are going and this is how your performance is going to improve, then it makes it much easier to sell. Does that make sense?
Yes, of course. Whenever we moving from new DASD device or whenever we upgrading the system to C16 or the C15, yes, it always will calculate the overall how much the performance at the MIPS level. When we talk to the technician, we always go with the MIPS number or CPU seconds. But when we go and talk to the management and tell them what is the benefit we're getting out of the upgrade, if they're moving to the, when we upgrade into the new DASD device, yes, we know that one, it's mainly, not in mainly, but most of the pack will get a lot of advantage out of the new device. But when we tell about the MIPS number, sometimes it's not going to make sense. But sometimes we have to talk about the number, money, the cost, how much is improved, how much we saving out of that one. So, yeah. I hope I
Okay,
answered.
thank you. Yeah, kind of. You know, it's an age-old question, really, of how to show the client, you know, to the best of our ability,
Yeah.
the perceived return. Yeah, tricky, but that's why you get paid the money.
Thank you.
Thanks, Mark. Thank you, Mary, for that. Okay, are there any other questions before we wrap up? Now is your chance. We've got a couple of minutes left.
Okay, thank you everybody for the time. Looking forward to talk in next GSE.
Yeah, that's November. Yeah, I'm looking forward to that too. It should be good. Thank you very much, Mary. This was 8F, I believe. So please evaluate, give evals. And we'll meet in just over half an hour again, which will be 8G, I think. But it won't be me chairing this time. Thanks, everybody. Bye-bye.